Before proceeding with the maintenance checks on the brake system, let's briefly explain the operating sequences. If the air system is depleted, when the engine is cranked over, the compressor initially draws air from the engine intake manifold. From the compressor, air passes through a small air reservoir known as a ping tank, the function of which is to absorb compressor pulsations and quieten the air system. The air continues to an air dryer and then onto a single element protection valve on the auxiliary tank. The governor valve and finally a multi-circuit protection valve controlling the air supply to the service and park tanks. At this stage, all the valves are closed. This means that although the engine is only being cranked, because the air volume in this pipeline is small, the pressure rises quickly. This enables the air throttle, which is fed from this line, to move the fuel pump control on the engine to full throttle in order to start the engine. As soon as the engine starts, air pressure builds up in this pipeline rapidly to 6 bar. At this point, the 2 service brake elements on the system protection valves should open, allowing air to feed into the tanks, supplying the front and rear service brakes. The air pressure in these tanks builds up to 6 bar. And then the remaining element on the system protection valve opens to allow air in the park tank to rise to a pressure of 6 bar. With the park brake tank at 6 bar, the system protection valve on the auxiliary tank opens, allowing air into this tank. With all air tanks at 6 bar, the system pressure continues to build up to a maximum pressure of 8 bar, which is controlled by the governor valve. When the governor valve opens, it operates an unloader valve in the air dryer, and all the air output from the compressor passes freely through this unit to atmosphere, thus taking the pumping load off the compressor. In addition, the inlet valve in the compressor is held off its seat, again providing a secondary unloader function. A check valve, located here on the air dryer, stops any air feedback from the reservoirs during this unloaded condition. Any water that may have collected in the air dryer is purged out through the unloader valve, at the point when the governor valve initially triggers the air dryer. Should the governor valve fail to open, a system safety valve located on the air dryer opens at 10.5 bar. It should be noted that the auxiliary tank on some vehicles may charge before the park tank due to air valve setting tolerances. This is quite in order and should not be identified as a fault. With the system fully depleted, start the engine and apply full throttle. The time to reach buzzer and warning light cancellation should be achieved in 2.5 minutes or less, and full pressure in 3.25 minutes or less. Providing the air system is in order, these charging times will be reached well within the limits specified. Should these charging times not be achieved, check for leakage on the following exhaust ports: the foot brake valve, foot brake relay valve, park brake relay valve, park brake valve, governor valve exhaust, air dryer exhaust, and finally the automatic drain valves on the air tanks if fitted. If no fault is found, next check for air leaking from the safety valve on the air dryer with the engine running. If there is no fault, next check all pipes and connections back to the compressor for blockage or loose connections. If no leaks are found, before finally replacing the compressor, check for air leakage on all auxiliary equipment, such as the doors and suspension. It should be noted that if any of the air components are leaking to the extent to affect the build-up time, the air leak should be very obvious and easy to detect. If all is in order with the charging times, our next check is for static leakage with the engine stationary. With the air tanks fully charged, observe the air gauges for a period of 3 to 4 minutes. During this time, you should not see any visible pressure drop. In order to monitor these pressures, you will need additional gauges for the auxiliary and park brake tank. Should the system fail to maintain pressure in the service or park tank, you should check for minor leakage on the following: the foot brake valve exhaust, automatic drain valve exhaust, handbrake control, handbrake relay valve, and finally, the foot brake relay valve. It should be noted, if the air pressure drops in the auxiliary tank, this could be the result of a faulty non-return valve in the air dryer. If the non-return valve in the air dryer fails, there are a number of characteristics that will be in evidence. The system will build up to full pressure of 8 bar. However, when the governor valve opens the exhaust on the air dryer, air will feed back from the auxiliary tank down to 7 bar, at which point the governor will cut in and the system will recharge back to 8 bar. With this problem, the governor valve will cut in and out rapidly. In addition, if the engine is stationary with the air pressure at or below 7 bar, air will gradually feed back from the auxiliary tank via the air dryer to the compressor. The rate of depletion depending on the compressor condition. It is important that if any one section of the air system fails, the protection and multi-circuit valves maintain a safe working pressure in the remaining parts of the system. To carry out this check, first fully charge all air tanks. Next, drain the rear service tanks by opening the drain tap or release the tank supply or outlet pipes. If the system is correct, the front service and park brake tanks will hold full pressure. The auxiliary tank will feed on to approximately 4.7 bar. However, to check the latter, a separate air gauge will have to be fitted. Should there be any pressure drop in the park brake or front service tanks, the multi-circuit protection valve is faulty. If the auxiliary tank fails to feed on, then the single element protection valve is at fault. The second check, again with the system fully charged, is to deplete the front service tanks. The rear service and park tanks should hold full pressure, and the auxiliary tank should again drop back to 4.7 bar. Third check is to drain the park brake. The front and rear service tanks should feed back to 4.7 bar, and also the auxiliary. To complete the test, drain the auxiliary tank. The front and rear service tanks and park brake tank should hold full pressure. Before proceeding with the application leakage tests, let's briefly look through the operating principles involved. When the foot brake is operated, air is delivered to the front brakes, and at the same time air passes through a relay valve, which allows air from the rear service tanks to the rear brakes. If the handbrake is on, to avoid compounding the brake operating mechanism, air also passes through a double check valve into the spring brake chambers to release the handbrake. When the foot brake is released, air from the front brake chambers exhausts through the foot brake valve exhaust. The rear brake release procedure is first air is released from the relay valve through the foot brake valve exhaust. Air from the service chambers is exhausted through the relay valve, and finally air from the spring brake chambers through a quick release valve. When the handbrake control is moved to the release position, air passes to a relay valve, which then allows air to pass to the double check valve, which seals off the service brake relay valve, which is in the exhaust position. Air then passes through to the spring brakes via the quick release valve. During the park brake application, air is exhausted from the relay valve by the park control. The relay valve in turn exhausts this pipeline to the spring brakes, and the main volume of air within the spring brakes passes out through the quick release valve. With the system fully charged, apply the foot brake, and because of the application, the front and rear service tanks will drop pressure slightly and should then hold. If, for example, the front service continues to drop pressure, you should check for air leakage on the foot brake valve exhaust port and the front brake chamber vent holes. However, if the problem had been with the rear service, again check the foot brake valve exhaust port, the relay valve exhaust port, the service brake vents on the brake chambers, and the spring brake quick release valve exhaust port. To complete the checks, move the park control to the release position. And if the pressure continues to drop in the park tank after initial application, check for leakage on the park brake valve exhaust port, park brake relay exhaust, the spring brake quick release valve exhaust. Before completing this area, you should be aware that a fault in the double check valve can cause a leak through the park brake exhaust when the foot brake is applied, or alternatively, when the handbrake is released, air can leak through the rear service relay exhaust. In addition, if the piston rod seal and the spring brake unit is faulty, this will also give the same result. The final test is to check the foot brake delivery pressure. To accomplish this, install the test pressure gauges into the ISO test points on the front and rear service connections. With the foot brake fully depressed, delivery pressures to the actuators should be at tank pressure. In addition, you should check during part application that the pressure readings are within a tolerance of 0.3 bar between front and rear delivery pressures. To continue, let's now look at the maintenance procedure on the air dryer. Contained in the air dryer are desiccant pellets. Under normal circumstances, these only need to be changed annually. However, they will become ineffective if they're contaminated with oil due to a faulty compressor. If you wish to strip the unit down, you must disconnect the outlet pipe to ensure that no air is present in the air dryer. A warning notice is provided to remind you. If there is any doubt as to which is the correct pipe to disconnect, release both pipes. To continue, remove the governor trigger pipe. Mark the end cover to ensure correct location when reassembling. And then remove the large circlip at the bottom of the unit. The end cover can now be removed. Next, unscrew the central container. With the container removed, access to the desiccant can be gained by releasing this lock nut and the central nut. The end cover is spring-loaded, so ensure that when removing the nut, the cover follows the nut back, unlike this example where the end cover has jammed. To continue, remove the top cover, spring and end cover to gain access to the desiccant. Moving now to the checks and maintenance procedures on the foundation brakes and actuators. First, inspect the brake linings. This can be achieved by removing this grommet on the back plate of both front and rear brakes. The linings should be changed when the lining thickness is reduced to 0.5 of a millimeter above the wear slot. The travel on the actuator push rods should be checked to ensure the automatic adjuster is operating. The travel on the rear brakes should be 19 millimeters, and on the front, 13 millimeters. In order to check the internal mechanism of the adjuster to ensure correct future operation, turn this adjuster screw anti-clockwise. This should, if in order, require considerable effort, and a loud clicking noise should be heard like this. If you do not get this response, although the adjuster may be working correctly, it may fail to adjust during the period before next service, and should therefore be replaced. If in order, by operating the foot brake some 6 to 7 times, the adjuster should readjust the brakes. A spanner placed on the adjuster nut provides an ideal indicator. If the pushrod travel had been excessive on your initial checks, make sure the brake mechanism returns fully, because the adjuster only adjusts on the final part of the return stroke. Therefore, if there is a partial seizure in the brake camshaft, or the foot brake valve is failing to exhaust all the air, this problem will exist. If there is no problem in this area, check that this bush is intact and not worn. To check the clamp plate setting, first release this clamp plate and push the control arm in the direction of brake application. If the lever will not move, the setting is correct. If the setting had been out, you will find that by operating the foot brake some 6 or 7 times, the pushrod travel will be reduced. If the adjuster does not respond after this exercise, it should be replaced. Always ensure that the slack adjuster is lubricated correctly. Otherwise, water can enter and corrode the mechanism, causing failure of the cone clutch and spring. To complete the checks on the braking system, ensure all pipework is clipped correctly and not chafing. Pay particular attention to the flexible pipes and ensure that on the front brakes, the pipes are clear of the tyre and wheel rim when on full lock. Always ensure that the steering box retaining bolts are secure. Check for oil leakage from the steering box, rocker shaft oil seal, and steering shaft upper seal. With the steering set central, inspect for free play in the steering. If movement is evident, check for lift in the 2 universal couplings on the steering shaft. If in order, check all steering ball joints for movement. To do this, move the steering under load. If a joint is suspect, it should be loaded axially to a load of 75 kilograms. This can be achieved using gland nut pliers. The movement when compressed should not exceed 2 millimeters. A dial gauge should be used to confirm exact movement. Should any further doubt exist, the ball joint must be removed and a check made on the torque required to rotate the ball pin, which should not be less than 2 Newton meters. If the steering joints do not comply, they must be changed. When carrying out these checks, ensure that each track rod articulates. If not, reset the ball joint. Whilst in this area, carefully inspect all the rubber gaiters for damage. Remember, the smallest of holes allow abrasive material into the ball joint, and although the joint may be serviceable, rapid deterioration will normally take place. Therefore, the joint should be changed if this problem is identified. All Lynx vehicles with a geared road speed in excess of 50 miles an hour are fitted with a steering damper. The damper is a sealed unit. Therefore, from a maintenance point of view, check for leakage and security. Moving now to the stub axle. The stub axle lift is controlled by thrust buttons between this plate and the kingpin. In order to check this clearance, place a dial gauge on the top of the assembly, with the dial gauge base on the axle beam. With the vehicle wheels raised off the ground, lever the stub axle upwards, and any clearance present between the thrust buttons will register on the dial gauge. If the clearance is correct, there should be a reading of 0 to 0.14 millimeters. If the clearance is in excess of this figure, remove the lower thrust plate and, depending on the correction required, remove shims to adjust the clearance within the specified limits. With the vehicle still jacked up, our next check is to establish the clearance on the stub axle bushes. To do this, place a set square in contact with the tyre. Apply the foot brake to eliminate hub end float, and with the wheel bar, prise the wheel outwards some 2 or 3 times. By using this conversion table, the tyre movement can be converted into bush clearance. If the clearance is in excess of 5.3 millimeters, the unit requires attention. If you wish to check the steering track, set the steering to the straight ahead position. Insert a peg into this centralizing hole in the relay lever. Next, check that the wheels are parallel to the chassis by using a gauge at the front and rear of the wheels. The gap should be equal. If not, lengthen or shorten the track rods to correct. However, after each adjustment, the vehicle should be rolled forward 1 complete turn on the road wheel to eliminate a tyre tread wind-up. The same procedure should be used on the other wheel. At this stage, the overall track can be measured using conventional equipment set to 0. Should any adjustment be needed, adjust each track rod equally. The Lynx has a hydraulic system to operate the power steering and hydraulic cooling fan. However, before dealing with the hydraulic system maintenance, let's briefly look at the hydraulic circuit and the basic operating principles. Oil is drawn from a reservoir by a hydraulic pump driven by the engine. From there, the oil is pumped through a line filter and then to a switching valve. This unit is responsible for distributing the oil supply to the hydraulic fan and the power steering unit. It also controls the oil flow rate and maximum operating pressures. From the switching valve, the oil passes to the steering box before returning to the reservoir. The maximum operating pressure when the steering is under full load is approximately 117 bar, which, as mentioned earlier, is controlled by a pressure relief valve within the switching valve. Moving now to the hydraulic fan. Providing the cooling water temperature is below 88 degrees centigrade, the oil supply from the pump passes through a thermostatic valve which holds the switching valve in the off position. And the cooling fan is not operative. However, a quantity of oil does pass to the fan motor, sufficient in most cases to rotate it at low speed, and then the oil returns to the reservoir. When the water temperature in the cooling system reaches 88 degrees centigrade, the thermostatic valve progressively shuts the oil supply to the switching valve. The switching valve now allows oil pressure through to the fan motor, driving it at high speed. The fan speed does vary depending on engine speed and oil supply pressure. For example, at maximum engine speed, the fan speed is approximately 2,500 RPM, with an oil pressure of approximately 84 bar. Moving now to the maintenance procedure on the system. The reservoir is here, with a sight glass for the oil level. The hydraulic pump is mounted on the engine timing cover, and the output for the pump passes through this small reservoir, the purpose of which is to damp down the hydraulic pulsations from the pump to reduce noise. From here, it then passes to a line-mounted filter and on to the switching valve, fan motor, and power steering unit. From a maintenance point, there are two filters in this system. This one is in the base of the reservoir. Providing the filter is only lightly contaminated, it can be cleaned. Be certain to tighten the filter to the mounting plate securely. To gain access to the line filter, unscrew the bowl unit. The filter element cannot be cleaned and should always be replaced. With any hydraulic system, be aware the smallest of dirt particles entering the system can render it inoperative. Therefore, take special precautions to avoid this happening. If the system has been drained, after topping up the reservoir, start the engine and idle for 2 to 3 minutes, and top up the reservoir as required. Next, move the steering from lock to lock. This procedure should enable the system to purge any air present in the circuit. Before discussing the air suspension maintenance, let's look briefly at the basic structure and operating principles. The front suspension consists of the axle beam, 2 taper leaf springs, which are fixed to the front end to locate the axle. The rear of the leaf is connected to the suspension beam, which is located by a tie bar to eliminate side movement during cornering. Mounted outboard on the beam are 2 airbags, which support the vehicle. Dampers are fitted close to the airbags and also inboard above the axle. It should be noted that there are 2 taper leaf spring locations. For example, this is the Mark I, where the spring passes through a fabricated beam and the Mark II, which has a tubular beam with a front fixing for the taper leaf spring. The rear axle again has taper leaf springs, however the airbags sit directly on the taper leaf at the rear. Lateral location is controlled by a tie bar. 4 dampers are again used, located on the axle beam. The suspension height is controlled by levelling valves. There are 2 at the rear and 1 at the front. The air supply for the suspension comes from the auxiliary tank via a pressure regulator valve and an airline strainer. If the suspension is deflated, the levelling valves will be in a feed position and allow air to pass to the air bags, allowing them to inflate. In the case of the front suspension, the air has to pass through an isolator valve before reaching the airbags. As the height increases between the axles and the chassis, the connecting linkage, which is attached to the axle, moves the levelling valve arm to a horizontal position, stopping any further flow of air and height increase. Should the vehicle load be decreased for any reason, the vehicle height will increase initially. However, the levelling valve arm will move downwards, allowing the levelling valve to exhaust air from the air bags until the suspension height is correct. If the vehicle load is increased, the opposite will happen. In the case of the front axle, when the vehicle, for example, enters a left-hand corner, the vehicle will roll to the right, causing the pressure to rise from this bag and decrease in this one. At this stage, there will be a tendency for air to transfer across, but the isolator valve stops any rapid cross-feed of air. In the case of the rear suspension, because there are independent levelling valves on each side, no cross-feed can take place, thus maintaining roll stiffness on the vehicle. When carrying out maintenance on the air suspension, with the system fully inflated, a check should be made for air leakage from the levelling valve exhaust ports, the airbags and associated pipework. It is important that the suspension ride height is set correctly. The measurement is taken here between the chassis and axle beam on the front suspension, which should be 80 millimeters. And in the case of the rear suspension, the measurement is taken here between the chassis and the H-frame, which should be 84 millimeters. It is important that the ride height is set correctly, as if the vehicle ride height is set too high, when the suspension moves upwards on rebound, the dampers may reach the full extent of their travel, causing damage to the damper and mounting plates. In instances where it's too low, a poor ride will result and damage to the bump stops may occur. Always ensure that the bushes within the tie bars are serviceable with no free movement. The airline strainer is located here, which contains a washable filter. To complete the air suspension maintenance, let's look at the techniques for airbag removal and replacement. Although it is possible to use conventional jacks, the most convenient method is to use wheel lifters similar to these. With the vehicle raised, place stands, in the case of the front suspension, here under the chassis member, at the front close to the radiator, and here close to the suspension beam. Next, disconnect the front levelling valve link and deflate the airbags. Remove the tie bar at the left-hand side. Release the airbag pedestal and lower the whole axle down until the full extent of damper travel is reached, and then ease the lifters up to avoid unnecessary loads on the dampers. Next, remove the airbag and pedestal from the locating links on the upper plate. Before refitting the airbag, always ensure all sealing surfaces on the pedestal are clean and free from corrosion. Lubricate with zinc steroid powder. At this stage, be aware that the airbag pedestals are different. For example, this is the Mark I and this the Mark II. And as such, different procedures have to be used to refit the individual airbags. On the Mark II, first engage the bags around these locating lugs on the upper plate. Then fit the pedestal. Engage the airbags on the pedestal. Operate the leveling valve to the feed position until the bags engage on the pedestal. And then allow the leveling valve to sit in a neutral position. At this stage, if the axle is raised on the lifts, the bag will roll onto the pedestal to its normal position. Finally, reconnect the linkage to the leveling valve. With the Mark I air suspension, engage the airbag onto the pedestal and then roll it down like this. The complete assembly can be installed as seen here on the rear suspension. Ensure that the airbag engages on the lugs on the upper plate. Inflate the airbag using the leveling valve, and then lift the axle up and the bag will roll down the pedestal. It should be noted that the tie bars on the rear axle do not have to be disconnected during this exercise. During this program, we have attempted to explain many of the main maintenance procedures to be carried out on the Lynx. However, always refer to the maintenance section in the workshop manual if any doubt exists with any of these exercises or seek further advice. Always update program information and manuals in line with any service bulletins issued. Use only recommended parts and lubricants. Follow the safety recommendations. Always be on the lookout for any vehicle defect, even though it may be outside your check routine. Remember, your ability to carry out the work effectively will make a major contribution to safety and vehicle reliability.